All right, Android Wear. I'm really excited to give you guys this talk. I started getting into Android Wear last year, I would say about March, April timeframe of last year, 2015. The Apple Watch was released around that time, and there was a lot of excitement at the company I'm working for around pushing an app for the Apple platform. So we decided, the Android folks, you know what, we're going to get into this Android Wear thing, understand the platform, and actually build a product and put a product out in the market. I did a lot of the development for that, a lot of trial and error, made a lot of mistakes. It was hard to find good documentation. Something's weird with the projector. Anyway, so it was very difficult for me to build an Android Wear app. It was really very similar to building an Android app for the very first time. The documentation, right now, it's really, really good, but at the time it was kind of very fragmented. Had to use a lot of different resources and pull them together to actually build an actual application. So I wanted to put a presentation, and I actually have a sample app that you guys can use that's open source on GitHub, and we'll get to that in a little bit. So goals for tonight, I really want to get you guys jazzed up for Android Wear. It's a really cool platform. You know, Android has been out for a while, and even though Wear is built on top of Android, it still is really new. And the use cases are specific. They're different. Design principles are different. It's very much like you're taking something that exists and extending it for something that's really small. You have to kind of rethink. I want to build this app. Wait a minute, I got to step back. Does this use case really belong on Wear? So I want to get you guys jazzed up. And also, when you leave today, I want you to understand some of the basic building blocks for building a Wear app. There are some very specific things, specifically the Wear API that we're going to talk about tonight. And I hope that we're going to dive into a lot of code. I have a lot of information to go over, but we're also going to dive into a lot of code. So I don't expect everyone to leave here with all this code downloaded in their head, but at least you can know some of the lingo, some of the terminology, and some of the basic Wear APIs that you can at least look up in the documentation and say, okay, I remember this presentation. Let me go into the documentation and start looking and doing a deep dive. So a little bit about me. I've been in Cincinnati my whole life. I graduated from UC. Even though our basketball team kind of sucks, it still was a really, really good school. I worked for 2 consulting companies. I currently work for a large grocery retailer. You guys can pretty much guess who that is. I used to love IGA. When I lived in Clifton, I would walk to IGA every day and buy stuff, even though it was really expensive. But so after school, I spent a lot of years in the Microsoft stack. So I did a lot of .NET development, a lot of SharePoint development, a lot of SQL Server development. And then it was great. I loved it. But mobile phones were starting to emerge around 2007, 2008. And I got my hands on my first iPhone around 2008. I actually built a SharePoint application on iOS when iOS 2 was released, so I've been doing that for a long time. And then eventually I didn't want to switch to AT&T because you only get an iPhone on AT&T, so I stayed on Sprint, got an HTC Hero, which ran Android 1.5. I think it was about a week later I downloaded Eclipse and the ADT tools, and somehow it's amazing to see where we are today. We have really rich tools. Android Studio, the emulator's pretty good. ADB's a lot better. But back then, it was rough. And it's really amazing to see. I think it's a really good time to be an Android developer right now. And I love La Rosa's Pizza. Unfortunately, we didn't have La Rosa's Pizza tonight. But if you know me, I'm a die-hard La Rosa's Pizza fan. So tonight, we're going to talk a little bit of the history of Wear. It is really new, even though Android's been out for a while. Wear hasn't. And what are the opportunities us in this room as developers, what kind of opportunities we have. We're going to dive into, app development. Like I said before, it's a different use case, and what use case really applies for Wear. We're going to spend a lot of time examining the Wearable API. So Google Play Services, the Wear API is a piece of that, and we're going to understand those different pieces it takes to actually sync data from a phone onto a wearable device. And then we're going to walk through a sample app that I put together. It's kind of a companion app for this talk. And then some lesson learned and recommendations that I can give to you guys after going through this journey. And while I'm talking about this stuff, I do have a couple Wear devices that I'll pass around. I have the really expensive Huawei watch. So this one, about $400. It's got a lot of bling factor. I really like wearing this watch. I'm very self-conscious of wearing this at the gym. So anyway, I'm gonna pass this one around. You wanna swipe up. If you've never used Wear before, if the device is asleep, you wanna tap the home screen to wake it up and go from right to left to go to the recent apps so you can explore. This one has Papercraft, which is like a little game. It's really neat. You can tap that and play the game. I'll pass this around. This one's the Moto 360. It's kind of been out for a while. It's a little bit underpowered, but it's still a pretty decent watch. And when Android Wear, looks like you already have one, so you can pass it on. That one does not have the cool game. This one does. This is the Samsung Gear Live. This was released at Google I/O 2014. I think Greg got a free one. So the game's on here too. You can just swipe from right to left to get to the recent apps, and you can kind of explore that as well. If any weird notifications come up, just dismiss it. It is paired. All of them are paired to my phone, so hopefully the wife doesn't send me something weird. Please do not. So the Wearable Opportunity. So March 2014, Wear was announced. It was basically an extension of Google Now cards to this new form factor, Wearables. But it wasn't shortly after. I think it was June 2014 at Google I/O. They announced an SDK, so you could actually build standalone applications, which is really what we want. Google Now is nice, Now cards are nice, but we really want to be able to build standalone applications. And the first version that Wear ran on was API 18 Jelly Bean. In 2015, we saw a lot more changes. This is the year the Apple Watch came out, and while it's a pretty decent device, I think it helped push Google to building more capabilities into the Wear platform and mature that platform. And we've seen tremendous amount of releases on the Wear platform. In May 2015, Wear 1.3 was released on the Lollipop platform, which created interactive watch faces, had Wi-Fi support, and provided always-on screen. So in November of this past year, Wear 1.4 was announced. I don't think it's been pushed to my phone yet, but they have improvements to the Fit API, new navigation gestures, and speaker support. So most of these watches don't have speaker support except for the Huawei watch. So once I get Android 6.0 pushed to the device with the new version of Wear, I'll be able to actually take phone calls without having to answer it and then speak on this thing. So that's going to be really neat. And I think one thing we got to be really cognizant of is Google always says Wear, there's always a better way. We're always on this thing, tapping away. We were at this conference today, and so many people were on their phones, constantly staring at this thing, typing away at this thing. Android and Wear, they really want you to put this thing away and just respond quickly to notifications and simple, quick interactions with your device, and actually get to the interactions that actually matter, which is people. This thing is great. I love these things, but really people and relationships is what we should be driving towards. And hopefully Wear and the apps that are on that platform help us reduce the amount of time we're on technology and actually increase the amount of time we're interacting with real people. And the beauty of Wear is OEMs cannot change the OS. They can bundle watch faces, they can bundle apps, but they can't change the underlying OS. So we all know Samsung, and we have to deal with that as developers. With Wear, you don't have to worry about that. The APIs that are on the that are released and as documented on the docs, you can trust those. And I think it's a real bonus for us developers. We don't have to worry about APIs getting switched on the fly for us. So Android Wear development, when I say different use case, They are Android apps, meaning you do have activities, you have fragments.
I have a question. Sorry to interrupt you.
Yeah, go ahead.
Okay.
Hmm?
Okay. You mentioned that OEMs cannot change the operating system, but can they build custom ROMs, like just take the basic source code and completely customize it, like CyanogenMod or something like that?
I don't know if bundling a watch face in a specific app that the manufacturer's released is a custom ROM. I believe no. Greg's saying no. So no.
No custom ROMs yet, because I haven't seen them around it. I'm curious
But so wearable apps are Android apps, but so here, this is what I mean by that. We have activities, we have fragments, we have services, we have intent services, we have broadcast receivers, we have all these major components that we know as an Android developer building apps for phones and tablets. We can reuse those things on Wear, but there's some things we can't. There's no browser, there's no print functionality, we have limited RAM, we have all these devices that's floating around only have a half a gig of RAM. So
I'm just curious, where do you buy this one?
That watch you can buy on the Play Store. So if you go to store.google.com, you can buy all these devices. I think you can go directly to Huawei.com and buy that device, but Google Play usually runs some specials and whatnot. I would just buy it directly from them. Google actually has a really good return policy as well. So if you don't like it, you can usually call them up and get it returned without a whole lot of hassle. But yeah, that's pretty expensive watch. It does have a sapphire screen, has a heart rate monitor, has Wi-Fi, has a speaker. And you get a lot of compliments. If you buy the Huawei watch, you'll get a lot of compliments, which is kind of cool. Wearable apps are meant to be small. So what I mean by that is not only the APK should be small. And the reason why is you don't install apps directly to Wear. The apps are bundled, with the main APK and the Wear app that runs on your phone. Push the app to Wear. So if you have a really big APK, a Wear APK with tons of assets, when the user installs the main APK from the Play Store, it's going to take a lot of time to push to the watch. So you want to keep your APKs really, really small. And you also want to think of a micro use case. What kind of feature that you may already exist on the app that you have on the phone? What small feature can you make on the Wear? Something that the user can finish in maybe 30 seconds. They can navigate to your app, respond to a notification, respond to some kind of action, and then be done. You really don't want the user on their wrist walking around and press, tapping and responding to things. It's really about taking a small, piece of functionality that you already have today and shrink it down and make it really quick for the user to respond to a task and then get on with their day. So when you go to build a Wear app, really think about how many features you really want to support. I would suggest just take one and get that right before you design two. Navigation gets really awkward. Once you support two major features and then you have deep navigation hierarchies, it can get really awkward in Wear. But for today, we're going to talk about, so with Wear, there's two different types of experiences. You have extended experiences with notifications. If your app supports notifications, you're already on Wear, but you can take it further. With the notification support library, you can actually build pretty rich mini applications that aren't actually an APK. You can bundle actions with your notification. So Pandora is a great example. There's no Pandora Wear app, but when you start a session with Pandora, so you start streaming music, you can thumbs up or thumbs down, you can raise the volume, you can skip, you can stop, all through just Android notifications. So not even an APK at all. We're not really going to focus on that today. We're really going to focus on standalone applications. So an app APK and a Wear APK. And we're going to focus on the data sync API. It's great to have an APK, but the data is what makes an app really, really rich. And we're going to focus on how to have those things talk to one another. So here's some of the main components. If you think of it from an Android Studio project standpoint, you're going to have your main app, you're going to have your Wear app, you're going to have your tests, and then your third-party libraries. So when you have your Android Studio project, you have your different flavors for your main app. Wear becomes another app bundled in the project. The Wear app and the main app don't exactly talk directly to one another. Google Play Services is the proxy between the two. So you don't really say, hey, Wear, talk to this phone. What you do is say, Wear, connect a Google API client, proxy this data to the other side. And you do the same thing. It's handling the two-way communication. And Google Play Services lives on both devices. And once you pair a wearable to your phone, Google Play Service handles all the Bluetooth negotiation and all the syncing for you. So when you're writing your app, you don't really have to worry about this whole Bluetooth thing. Google Play Services really handles that. But today, the Wear API really has three major APIs, which is the Node API, the Message API, and the Data API. And we're going to be breaking down each one of those, talking about their capabilities, and then we actually look at the sample app. We'll see how we use each one of those to talk across the air, so to speak, between the two. All of these are inside Google Play Services Wear API. So if you're already pulling in Google Play Services for Maps, there's another one for Wear. So when you're building your app and you're in your build your Gradle file, you'll add another one for Wear. Node API. The Node API is all about discovering connected nodes. So I got some code snippets, and we'll review that here in a minute. But the Node API allows apps to get notified when connection state changes. So right now, I'm pretty much in range of these apps, so my app is still connected. But if I turn my app off, or I wore my Wear to track my run, but I left my phone at home, you can use the Node API to get notifications where, okay, now I'm disconnected from here. So maybe I want to stop trying to sync data items across the wire. Maybe I just want to keep that in some kind of local cache. And then when I become within range, the Node API will give me a notification, and I can start that sync process. So if you look right here, one thing that's neat about all the Wear APIs is they both provide a synchronous and an asynchronous function. So you can do this. You can ask the Node API for, hey, what are all the connected nodes? How many watches are connected to me right now? And if you want to do that in a synchronous fashion, you still have to do like an async task or an intent service to do that. Or you can just, actually, I think, I don't have the asynchronous portion right here, but the capability is there. So inside here, the pending result nodes equal wearable. So when you want to use the Wearable API, it's always wearable.node API or .data API or .message API. You always start with wearable dot, and you can get to all the APIs you need to sync data between the two. One thing you're going to call get connected nodes, and you're going to pass in a Google API client. Every single one of these needs a connection to the Google API client. And we'll see that more when we go into the code. And then you can see right here, this is kind of another line. So set result callback, this will be an actual asynchronous call. And when you do get connected nodes, or not connected nodes, Google Play Services says, hey, here's the nodes that I know about. You'll get this in this on result. And then you can loop through this result and get all the nodes. So on the watch, it's not that interesting because a watch can only pair to one phone, but a phone or tablet can pair to many watches. So on here, I'm connected to 3 different wearables right now. So I may want, if I want to sync data to all 3 of them, I need to make sure that I'm getting this node ID. I want to loop through and store this node ID because my app may exist on multiple wearables. Message API. This is used to send messages in small byte arrays between devices. And these messages are filtered by path. So you can see right here the same nomenclature, wearable.messageAPI.sendMessage, pass in a Google API client, pass in a node. You have to have a node ID, and then you can create a path. So think of it as some kind of, you can come up with whatever URI path you want. And what this looks like at the end of the day is a URI that looks like where : / node ID / whatever you want in here. And this parameter right here is the actual byte array. It's optional. You don't have to send byte arrays across the wire. I typically like the URIs. If I wanted to send a message from the wearable to the phone, and I want to complete and have the wearable say, hey, phone, do an action, I usually spell out the action / object ID. When I get that on the other side, I tend to parse that. That's if you want this to kind of be your master. This owns your data, your object graph, and the wearable is just saying, hey, perform this action on this object ID. But if you want to actually, and you can put the ID inside this byte array, or you can create a path. It's really up to you. And then right here on the receiver side, so this is the sender, and this can be used on both sides. You can do this on the watch, and you can do this on the phone or tablet. So this is the send a message. On the other side, there's this on message received. Hopefully you guys can see that. And this will give you the message event and a message event.getPath, and that will return this. So you can parse this and perform whatever action you want on your object graph. One thing to note is there's no verification. So if you say watch, hey, send this message, the watch will never get notified that it actually was received on the other side. It's kind of like set it and forget it. The only result you get is Google Play Services got your message and it attempted to send it. It does not know if the other side actually got it. So if you really need this handshake, send a message, got the message, received the message, you really have to program that in. You don't get that for free at all. But if you connect to the Node API, make sure you have a connected node, and then call the message API, you really don't have to do this handshaking. A good practice is always connect to the Node API and make sure you have connected nodes before you start sending and receiving data items and messages. The data API is the most interesting. So the other two aren't as interesting as this one. This one is basically a shared cache between both the wearable and the phone. And this shared cache is automatically synchronized between both devices, actually all devices. You can put data in. Even if you guys took that watch somewhere else, it became disconnected, I can actually put a data item in the cache, and when that device was nearby this, Google Play Services will automatically sync that item to the watch. You don't have to worry about that, which is kind of nice because if you need kind of offline capabilities, so if you don't want to force the user to always be near this to get your object graph across the wire, you can use the data API, sync it, and then you can kind of live in this disconnected world. You can make updates here, you can make updates here, and Google Play Services will determine when to make the sync. It's again by paths, payload, so you can put this thing called a data item inside the data API. It's basically primitives, so strings, booleans, integers, floats. It's basically like a bundle. So if you're very used to bundles and intents, the data item is that. Underneath the scenes, it's a byte array, but working with byte arrays can be really painful. So Google gave us this thing called a data item, which is a map of primitives. And the cool thing is it's really SQLite backed. Underneath all this, when you actually request for data items, you get this thing that's really a cursor. It doesn't say cursor, but it really is a cursor. So as you loop through these data items, you need to make sure you close them out because you're really getting a cursor to SQLite, and you need to release that. If you're using the newest version of Google Play Services, which is 8.3, they added this thing called an urgency feature, and this can burn you if you don't know what that thing does. So previously, before 8.3, you can put an item inside the cache, and it won't sync it across the wire unless the data actually changed. So if you had like an array list of strings and you put that in the cache, it syncs. Even if you made no changes, nothing will happen. If you wanted to force a change, you actually had to put some kind of timestamp in there inside your object graph to force Google Play Services to sync it across the wire. That was kind of like a little trick. Well, with 8.3, that kind of stopped working, and it really was pulling my hair out. Well, they had this thing called urgency feature. If you don't set your data item as urgent, it could take up to 30 minutes for your data item to go across the wire onto the watch and back. So if your use case doesn't need real-time connected data, that might be okay. So like say you're running, you don't need the data on the phone instantaneously. That might be okay for there to be a little bit of delay. In reality, what I've seen is basically 5 minutes. So I've not seen it go as long as 30 minutes. If you don't set your data item as urgent, 5 minutes is basically, you can see it across on the phone or the watch. So it's typically 5 minutes. It can be up to 30 minutes. If you set your data item as urgent, it's instantaneous. So I just default to urgent. So what does this look like? Again, so here's some code. This is code that would be on the phone, and this is some code that would be on the watch when you're working with the data API. You'll start out with this put data map request, and there's a static .create, and you'll put in a path. So again, it's by paths, and this will become really important over here because you'll get a data item, and you'll get all kinds of data items related to your app, but you'll want to actually parse the path that you put in here to make sure you're actually operating on the right data item. Inside here, you'll get a data map. So underneath this is a byte array, but this is where you put your primitive. So inside here, the data map put string array list, and this is just a simple string array of names. In this case, you'll see where this code matches up in the sample app, but this is just a string of names. And then again, you get wearable.dataapi.putDataItem, an instance of the Google Play Services client. Your data map request .as_put_data_map_request. This is all really awkward. It doesn't seem to be a whole lot of rhyme or reason with the name, but if you just follow this pattern, a lot of this will work. Set a callback. And again, this on result, at first, I thought this was actually verifying that it sent across the wire. No, this just verifies that this data item was put in the cache. Does not verify that it actually made it across the wire. Just, okay, I was able to connect to Google Play Services. This data item looks good. It made it into the cache. And then on the other side, we have this thing called the on data change callback. So you implement an interface of the data API, you'll get this on data changed method, and you'll end up getting this data event buffer. This data event buffer is essentially that cursor that I was talking about. You can get items out of it. In this case, is this event.getDataItem. This event would be associated with this path. So in this case, I really should be checking for the path before I started operating on this data item. But the important thing is this on data change. If on this put data map request, you can set this thing as urgent, and it pretty much instantaneously will show up on here. All right, background processing. The Wear team made this super, super simple. So if you have an activity that's in the foreground, you can implement these callback interfaces to get changes on data items and get messages. But often our apps aren't in the foreground. They're in the background, your phone's in your pocket, but you still want to be able to interact with data on your phone, or not on your phone, on your watch, and have the phone respond to it. So they have this thing called the Wearable Listener Service. And this is a typical Android service that has two main callbacks, this on data changed and on message received. So once you extend the Wearable Listener Service and register it with your manifest, Google Play Services will manage the lifecycle of this service. So your app doesn't call it, your app doesn't start it, you don't bind to it. Google Play Services will warm this up, call these things, run your code, and call on destroy and shut it down. It's really, really neat. So you can actually go inside your app, clear it out of memory, nothing's running, make a change on the wearable, and Google Play Services, when it receives that change, it will fire the Wearable Listener Service, go through the life cycle, process this data, and then shut it down. Now, with that means you need to think about broadcast receivers or content providers or some mechanism that if your app is in the foreground, how do you get the data, once it's processed, sent back to your activity? So you'll need to have some kind of storage mechanism or broadcast mechanism to say, okay, this received a message, I'm done processing. If I'm in the foreground, what do I do with it? Somebody needs to be listening for that. But yeah, this thing, I suggest when you build a wearable app, also that you use this right away. Oftentimes, I put these callbacks inside the activity, and then realized pretty quickly I need a background service to perform most of my work. So if you just start with the Wearable Listener Service, and this thing works on both sides. So you can use this service both on your phone and your wearable. It works for both. All right, sample app. Any questions, or everyone good? Okay.
Last thing, you update code in the wearable listener interface, or that's just an interface you don't purely abstract, right?
Yeah, you just implement the interface and then.
So, but in the sample code you showed us, there was no processing unique to yours. It was just an invocation of the soup. So.
Yeah, these are just the. Once you extend that, you can override these two methods and do.
In each of those.
Huh?
In the overridden functions.
Yes.
Or methods, overridden methods, you add your own code.
I didn't add any code here.
This is just a demo that shows you should call the super, but then you also add your own code.
Yes, and we're going to see real code. I couldn't fit any real code in here.
Yeah,
I just wanted you to see that these two methods are extremely important if you want to process items from the data cache or you want to process messages based on a path. That's what these two do. We're going to see real code here real shortly. Sample app. So, I built this app called the Romance Tracker because it's, February, Sunday was Valentine's Day, and, huh? Well, you got this, you got your fitness tracker, you got your, food and health and calories. So what about hugs and kisses? What about tracking romance? We need help with that. So I thought this was something, it was a good use case for Wear. And just be able to say, okay, I kissed my wife today, I gave her a hug, I gave my daughter a hug. How much am I really doing that? Am I really, treating these ladies, like I should? So these are the features of the app. You can add, what I call sweeties, your sweeties to a list. You can use the Wear app to add hugs and kisses to a number of sweeties, and then you can track each one. And this app really is for you guys. It's really to showcase how to sync data between the two. We talked a lot about this, and we showed some code, but this is something that you guys can can go download and use as a template, because there's a lot of stuff, a lot of plumbing that you can just download this and get going with it. And one thing that's really cool about this app is it does use the Fragment Grid Pager adapter. If you haven't used this yet, it's kind of like a 2D rows and columns of fragments. So we're pretty much used to like a grid pager or a view pager, and you kind of page through fragments. This is like rows and columns of fragments, which is really neat. And there's this thing called an action button that we'll show. So on where most notifications, after you go through the notification, there's this big blue action button. You can either open the app on your phone, you can delete an email, you can fast forward if it's Pandora, or pause. This is kind of a known UI use case in Wear is these action buttons, and we can use those in our apps. So here's some of the main components. I just wanted to review the different components so you got to get a sense of how the app is put together before we dive into code. So the main app is basically simple list view with an array adapter. We're going to make heavy use of the Google API client, heavy use of the Wear APIs. We're going to see the Wearable Listener Service in action. We're going to look at Local Broadcast Manager to, after this thing is processed data, we're going to use this to notify our activity, hey, this data is ready to go, refresh your screen. And we're going to use shared preferences to as a data store if my activity isn't active. So if it's backgrounded or it's destroyed, the Wear Listener Service will store data here. On the watch side, we're going to look at these are the components we're going to look at. We're going to look at the watch view stub. I'll explain that later. List view, the Fragment Grid Pager adapter. We're going to look at card view, action page, Google API client, and the Wear APIs. So it's a lot of stuff, and that's what's great about this app is when you guys download it, you can see all these components working together. I've had to spend a lot of time understanding each one and how they fit together. And there's actually specific things over here that you're not used to doing over here. Once you start building a Wear application and you're used to doing list views and complicated card views, and you have all these complicated layouts you're inflating, Wear, you don't want that. You may just want one or two text views. You want a simple list view with just one text view, or just a card view with a small image and some small text. You really have to think about, from a design standpoint, how do I want to transfer this user experience on the phone to the watch? You really have to trim things down. And I definitely encourage you to go to the design specifications for Wear. Google has laid out some specific specifications on navigation. Navigation is very important. This app doesn't exactly follow some of the specifications with navigation. How you use cards, what are the appropriate use for cards? What's the appropriate use of action pages? So I would encourage you guys to go look at those documents and read the use cases before you just go and build a watch app and it's kind of awkward. And also study the apps that come with Wear. So the Gmail app and the Hangouts app, Calendar app. Look at how they use cards, how they use list views, how they present images and assets. You really want to mimic that. You really want your app to look part of the platform and not something that's kind of awkward and off to the side. And the best case is to look at what comes with Wear and mimic that. All right, we're going to dive in some code here. All right. All right, Android Studio. So you can see right here we have both the mobile application. So this is the app that runs on my phone, and we have the wearable application that runs on the watch emulator, which I have running right here. And there's lovely Greg. So I'm not going to spend a lot of time talking about setting up your development environment. The documentation's really solid on how you really need one device. You can't run two emulators. So you can't have a watch emulator and a phone emulator. You really need a physical phone, and you can run the watch emulator. And you can run this ADB command to sync to connect the two. And that's on the documentation. So we have the mobile app. We have the Wear app. We're going to go ahead and look at the mobile app. And actually, before we go in the code, let me actually show you the app so you can kind of get a sense of what it does while we walk through the code. All right. All right, romance tracker. All right, so I have 3 sweeties right now. Stacy's my wife, Sophia's my daughter. This is just test. We'll go ahead and bring up the watch app, and we have the same one. And it's pretty pink because it's Valentine's Day. So, it doesn't actually always have to be ladies. Adam's my good friend. I may want to give him some bro hugs, so I'll go ahead and add Adam here. All right. This.
I thought you said you couldn't have a phone emulator and a Wear emulator on at the same time.
He's using Visor.
You seem to now.
So I'm actually using a real physical device. This is a program that can mirror my screen.
Oh, okay, that just mirrors the screen on the
So,
device.
yeah.
Okay. Does that go in the Android Studio? I'm not familiar with that.
This right here?
Yeah.
No, it's this program that I downloaded called AirDroid. It.
Oh, you mentioned that. I didn't catch it. Sorry.
Yeah, Google has one called Visor. It's a Chrome plugin.
What'd you say, Greg? Couldn't hear you.
So Google has one called Visor with a Y, V-Y-S-E-R.
Okay.
Yeah.
It's a Chrome.
Yeah. Yeah, there's nothing special. It's just a mirroring application, so I can show you guys what I'm doing here. And this, see, because I'm running 2 apps and one emulator and a phone at the same time, and I want you guys to be able to see the real-time sync. And you did see that Adam showed up over here. I'll go ahead and add another one. I'll add Gracie, which is my dog. And you can see right here, Gracie showed up. So what's happening right now, and we'll get into the code, is I'm adding another person to this array list, which I'm calling sweeties. These are my sweeties, and I'm putting them in the data API. So these are called data items. That string array that I showed earlier, that's getting put as a data item on a path. I'm telling it, oh, this is an urgent data item, and it sends it to the Wear right away. So we can go in here. So Stacy, my wife, I got a card, 2 cards here. So this is the 2D fragment pager is what you're going to be looking at right now. So I have a column that's got 2 cards. So this is row 1. This is row 2. The first row handles hugs, and then I can so row 0, column 0 is this card view, and then when I swipe, I have this what's called an action page, and these are these blue buttons that are kind of grayed out that you get for free when you use this action page. And this is something that people who use Wear will know right away. This is something I can tap on to complete an action. So I can track big hugs and small hugs. And if I swipe, I get my kisses card, and I have a big kiss and small kiss. So go ahead and give a hug. And it is supposed to do something, but it's not. So you can see right here, this says the message, send message result success. So that's what I'm saying. It's not guaranteed to go across the wire because I haven't received it yet. If I did, something would update over here. It's not updating. So I've actually said, hey, on the Wear, this is using messages. So actually I put the data across the wire, and when I tap on one of these, on these buttons, I'm actually saying message, perform this action. And when the phone gets it, it's gonna see that action and then update the data model, send a broadcast, and update the UI. it's saying that there's success there, but there's no success. So it just says, yeah, I sent the message, but obviously nothing got received, so there's no guarantee of success. We need to figure out what's going on here.
Sent over this way.
Well, so this is message. There's actually no data being sent across the wire. It's just a message. Oh, you can see this right here on data change. Let's go back a little bit. When I brought up the app, when I'm on this screen and I'm adding items, data items, you can see here is the on data change being called, and here's the URI with the where : whack whack. This is the node ID. That's identifying that emulator, and then this is the path for this particular data item. That's an array list, just a string array list. So let's see if we can get this message thing to work. Not really sure what's going on here. Disconnected. This isn't good. Well, I've noticed, okay, so the emulator, when you build one of these, try to use real devices. I've noticed this emulator, it sometimes doesn't want to always talk to this, because it's communicating through TCP, through ADB, and sometimes it's a little janky. If you use a real device, you get a lot more success with sending messages and processing data. So if you're really going to commit to building a Wear app, just buy some real devices. I've run into this while building this, and I've never been able to figure out when it starts working and when it doesn't start working. But let me go back in time here. And see if I can show you guys it actually working. So the branch that I was on is using the Wearable Listener service, and it doesn't seem to always work when I'm using the emulator. It seems to work much better when I'm using physical devices. So let me build and redeploy these apps and see if we get a little bit more success. And if this doesn't work, then we'll just dive into some code. While that's building, we can look at some right now. All right, so this is the list of what I'm calling a list of people activity that's on this. So that's this right here. It's just a simple activity, but you can see right here that it's implementing the Google API client connection callbacks, the Google API client on connection fail listener, and the message API message listener. Beach balled for some reason. Looks like Gradle's still building, so we'll look at some code while it's still building. The first thing you want to, yeah, let's see, view, enter presentation mode. There we go. All right. The first thing you're going to want to do is connect to the Google API client. So you want to create a field because you're going to use this a lot. You definitely don't. You want to close it when you're done with that activity, but while you're on this activity or inside the Wear Listener service, when you make the connection, create a field so you can kind of reuse it. All right. So on resume, you can see right here, we're calling the Google API availability get instance. All right, this thing's still loading. This is really the meat of what you really want. You want to create a Google API client, use the builder pattern. You want to add API, the wearable API. You want to set the connection callbacks and the connection failed callbacks. So that's just this, and then build and call .connect. When you call .connect, it will call into these guys. So you can see on connected. So once you are connected to the Google API client, now this is a little confusing. You're just connecting to Google Play services. You're not actually connecting to the watch at all. This is just giving you a hook into Google Play services. And you can get some errors here as well. And that's what this is. On connection failed. If there's something wonky with the API version, that what you're building for, and then when you put it on the device, it doesn't match, you can get some failures. But for the most part, it connects all the time. And then what you're going to do inside here, you can see the wearable message API add listener. So I'm going to start listening for messages. So this activity is going to listen for messages. And you can see I'm giving it the Google API client and then a handle to this activity. And I'm going to call an async task to go ahead and get the list of sweeties. So inside here, we have the put data map request, giving it the URI to that data item. You can add more and more data items into the cache. You just have to qualify it with another path. So if you have an array list of names, you give it a different path. If you have a different object graph you want to send across the wire, give it a different path. Here is the set urgent. So for this request, we want to make it urgent. We're going to get a data map. And then I'm just going to take this new array list. I'm going to add all these names of sweeties that I added, put it in the data map, and then tell the wearable.data API, put data item, and then call the put data map request .as put data request. The method names are really awkward. It's what I've noticed with this. The method names are really awkward, and if you just follow what's in the documentation, you'll do fine. So this just puts it in the cache. Doesn't do anything else but put it in the cache. But we really want to see is the other side of the pipe. Let's see if this thing was going to work now. Demoing one app is pretty difficult. Trying to demo two at the same time is sometimes a little harder. All right, so here we go. Nothing. What the heck? This is really unfortunate because I know this worked. All right.
These are the watch. You have 3 watch, right? Can you try on watch?
Well, let's. It says it's connected to the emulator. This doesn't make a whole lot of sense why this isn't working. Let's see if we can try to debug this thing. All right, so we're going to go to the where side. You're going to see a very, you'll have to trust me, it did work. I'm not sure what's going on right now. Maybe it's because I have 4 devices connected to it, it's acting up. But you're going to see a very similar pattern. So this is the list of people activity for the watch, and it's implementing the same callbacks. So we have the Google API client connection callbacks, the connection failed listener, and then we actually have something a little bit different here that we didn't see before, which is the data API data listener. So we're going to, on resume, we'll make a connection to Google API client. And I'll touch on some of this watch the watch stub views and some of this caching stuff here in a minute. But once we make a connection to the Google API client, and this is pretty much this exact same code on the phone side, once we make a connection, we're going to check the cache. So in this case, after Google Play Services synced it to the wearable, I could actually turn my phone off and it will still be cached on the wearable. So you can ask the API client, the data API, hey, is there anything in the cache? If so, go get it out. So that's pretty neat. That's what this is doing right here. This wearable.data-api.getDataItem, pass it your Google API client, and you're going to get this results callback. And then I'm going to get you can get a list of data items. In this case, I only put one, just that sweetie list. I put the data item in there with just the sweetie list path, so I only have one. I can get that out of I can get this data item out of this pending results. What you can see right here, this actually gets the data map out from the data item. If it contains, so here's that same path, contains key, that's the path that I used on the other end on the phone. And then you can see here, I got the array list out, and then I'm updating the list view. And then right here, this is really important, the call release on your data item, because at the end of the day, that's really a cursor, or it's backed by some kind of cursor. So you want to release that. If you don't, you'll get memory leaks and you'll get logs in Logcat to tell you that you have memory leaks. Okay, so let's see why this isn't working. I'm going to disconnect some of this stuff. Maybe this didn't update to what I wanted. All right, let's see here. This is really frustrating, guys. I have to go back and check out another branch. So what I wanted to show you guys is apparently the Wear Listener service isn't working, but what we can do is, I wonder if we can actually just force this to work. Actually, we're gonna try to use the message API here and see if we can actually get a message to show up. My computer's running really slow. Yeah, I can't even get.
Yeah, I think it's okay. We trust them. If not, I need to go there.
All right. Well, maybe after we can try to figure this out. I'm really sorry that this is somehow not working. But all right. Well, let's just look at this in a little bit more detail. Grid pager fragment. This thing right here. This is something you'll probably use quite a lot when you're building a Wear, is using the card view and the fragment grid pager. That's what you can create different actions. That's how users are going to be used to navigating through your app. This thing is pretty awesome, actually. So you can create an adapter that extends the fragment grid pager adapter. And what you're going to do is create rows and columns of fragments. Let me, if I can go back to presentation mode. I think I'm running out of time because it is 7:40. Right here, you can see inside the constructor, I'm calling create action pages, and I'm creating row 1 and row 2. These are the actual card fragments, and inside the row, I'm going to be creating the columns. Each row is going to have a column of action pages, and that happens inside the constructor of this class. And then this right here, this get fragment. So versus get view, this thing calls get fragment. And you can see so this is a list that's managing all my fragments, and I can get a row, get fragment with a column. So versus bind view and get view, you really have get fragment. And then right here you have your row counts and your column count. So inside this action page list, I'm getting how many columns I have, and then for the row count, so I have two rows and 3 columns in this particular case. And inside this romance action, he is he's creating the hug action and the kiss action, and then the 2 big actions. And it, action capture fragment or activity. We'll look at this real quick, and then we'll probably, since it's getting late, we'll move on from this code. Unfortunately, it didn't work. But you can see right here when the user taps on the actual action button, we're connecting to the Google API client again, making sure that we actually can send a message, and then we're calling send action message. Wearable.message API, send message. I'm giving it the API client. I'm giving it the node ID, and then the URI that indicates this, this sweetie, this action, a big. So it's pretty much like, Stacy, big hug, Sophia, small hug. That's what this URI is, and that will go to the wearable listener service, and it will parse that and actually update the model. It looks like I probably should have looked at the Node API before I call this. Looks something's not happening across the other end. It looks like my phone can talk to the wearable, but the wearable isn't talking back to the phone, and I'm not really sure why in this case. And one more thing, and then we'll go on with the presentation. I want to show you the wearable listener service. I don't want this. So here is so in order to keep tracking hugs and kisses from the watch to the phone, when my phone is backgrounded, you want to use the wearable listener service. And let me actually put it back in presentation mode. The wearable listener service is going to implement in this case, I'm not doing anything with the data items. So here's the on data changed callback, but right here I am processing the messages. So that path gets sent to the on message received. If it contains the /action, I'm going to start processing these different actions. So inside here, unfortunately you can't see because it's not working, but it's where the node ID /action / the sweetie name / hug or kiss. So if I break that apart, if the length equals 5, then I'm going to start actually breaking that down. I'm going to record the action in my model object. I'm going to save that to shared preferences, right here, and then I'm going to send a broadcast. So if the activity is in the foreground, I'm going to create a local broadcast manager and say, hey, this data has been updated. Rebind the list view.
When you get the path, do you get the full path or just the part after the node ID?
Let's see here. So it looks like it's kind of broken down. So you can get the source node ID. Yeah, but that path just gets you after the node ID. Okay. But if you want the node ID, you can get it here.
Okay.
So I really apologize that the app didn't work. It's extremely disappointing. We'll have to figure out that here in a little bit. Let's go back here. All right, so learnings and recommendations. So when I first started doing this, the Wear documentation was definitely lacking. I had to use a whole bunch of training docs. The training docs are pretty good, but they'll give you slices. They'll teach you the data API. They'll teach you the node API, or they'll teach you the message API, but they won't they won't have them all together, or they won't go through the 2D fragment grid pager adapter. It's very fragmented. The Google Play service is also not open sourced. So when you try to decompile it, you get a lot of obfuscated code. So you try to dig into the put data map requests. If you want to look at the paths and how that's generated, and you want to see the internals, you're not going to get a whole lot out of it. It's just a bunch of Z's and A's, and you're going to be left. And there's no Java docs either inside the Google Play services. So you're kind of trial and error. A lot of this is trial and error. If you're using multiple Google Play services, make sure the APIs match. So don't try to use 7.3 for maps and 8.3 for Wear. It won't work. You have to use the same API version. And then definitely study some of the design principles. I think I've hit that a couple of times. And then think about asynchronous processing from the beginning. Everything in Wear is asynchronous. Nothing is guaranteed. No connection is guaranteed. As you can see, I had a lot of problems getting data from the watch back to the phone, but from the phone to the watch worked. You don't want to be blocking the UI thread, so make sure you do everything in an intent service or an asynchronous task, or use the asynchronous callbacks that each Wear API gives you. And be defensive, never assume a connection. I think that's what My problem was with after you tapped the actions for the hugs and kisses, I kind of assumed a connection. There seems to not be one right now. I'm not really sure why, and it's not working. And the Wear emulator is decent, but use a real device. I think the Moto 360 is pretty cheap right now, maybe $100. So if you just want a little bit less, so if you want something just to test on, just go get one of those. I don't think you would have some of the problems that I had today. And then here's some training resources that I used to build this presentation. These YouTube videos, the Google I/O 2014 and 2015 have some really awesome videos. The training is a good place to start. And then there's some stuff about how you package your app for deployment. We didn't really talk about deployment. That can be a whole other talk right there. And then here's when we upload this deck to the meetup, you can download the source from GitHub, and you can at least see how all this stuff works. I know we kind of jumped around all over the place, and I apologize for that, but you can at least have something that to start with. So that's it. Any questions beyond? We are at 7:50, so we can.
Get your watches back?
Yeah, where are those watches?
I mean, maybe this is not for you. I think it's for everybody. I mean, what's the future for those wearable? I mean, it's like phone, right? Everybody can have one. So, like wear, I mean, it's like you don't feel that's really need. I mean, both. I mean,
So
for the meeting, I mean, some conference. I mean, maybe for everybody, and everybody see what's the future of wear.
So, do you really need it? That's kind of like that's a personal thing. I mean, I can almost say, do we really need this in some respect? The future wearable, I think the watches are probably a first-gen wearable. I have this little thing right here that's super small. It's even considered a wearable. It's got a little accelerometer and a temperature sensor and then a little LiPo battery that lasts a really long time. And you can make this a wearable. Wearables, I think Google's been doing some stuff with fabric that can conduct electricity and track things and connect wearables to. I think we're just really at the beginning. We're just still trying to figure out what wearables are. I think watch is a decent use case, but and the glass turned out to be a pretty good use case, but the watch kind of dominated. I don't know. I think as long as we miniaturize electronics more and more, we're probably going to see things that are a little bit better than watches. I mean, watches are a very personal thing. I consider watch a jewelry piece. Some people substitute the jewelry piece for the Fitbit. I really like going out to a restaurant with a nice timepiece. Not necessarily something like the Moto 360. I like the Huawei watch because it's got some bling factor to it. And I have a lot of really nice watches, and it kind of makes me upset that I have to give up that investment in my watch collection for Android Wear, but it provides a lot more value than just a timepiece. So I like to really see things that are a lot smaller, that are a lot more durable, that are more interchangeable in the future. Something maybe in glasses.
The Nexus show.
Have you seen like an Android watch with a microphone in it yet? Because I think that would be really cool.
So all those watches have microphones in them.
They all have microphones?
Mm-hmm.
Yeah, they all do.
Yeah.
Any of them have cameras?
Hmm?
Any of them have cameras?
No, camera is horrible.
No, they don't.
Privacy.
Those don't have cameras.
There's watches out there that do.
Are
Is-
there
I think there's
Android
a
Wear
Samsung one
cameras
that
that have
does.
are there Android Wear watches that have cameras?
Oh, that's right.
I don't think so right now.
Yeah, if you put camera, then if you go to like bathroom, it's you way to privacy. I mean,
Yeah.
the company should be very careful to add a camera to the watch.
I mean, the speaker support that's in the Huawei watch is going to be pretty big, but
Not have to take this out and do a voice.
Do you know if there?
Does the Wear API work with Android
with glass. I don't know, Greg, do you know?
Yeah, it does actually. Glass is not on Android Wear. I mean, they were supposed to go to it, but then it just gets stuck at GDK. But it never, Android Wear was never ported to. I mean, that's probably the next thing. What will happen when they come out with the enterprise version of the glass or the next version of glass, hoping that Android Wear will be supported on glass. Because right now it's that GDK. Yeah.
So to develop apps for glass, you have to do a special GDK.
Yeah, so for glass development, like, you know, the thing that we use, they have something called the two different types of glass hardware, some glass apps. I mean, you can have what we call the mirror API, which is something that is like totally, it's not really an API or anything that you install on glass, but then it's kind of web-based, you know, and for the glass development kit, there is a GDK that you can download, and then really write kind of like, you know, Android where you get the APK installed. Yeah, it's really hard.
See,
Because
they
they
get
tell
that.
it
Or will this tag out or
But-
watches?
I mean, the nice thing is the stuff's really new. I mean, it's not even 2 years old. So we have an opportunity to make something.
Wear API was announced in March of 2014.
Mm-hmm.
How long have you been working, developing on it?
I started working on Wear development, I say, March, April of 2015.
So a year later, you started, you were doing it for about a year.
Yeah.
Do you know if Android Wear works with Chromecast? Can you use it to select items that you're going to cast?
I don't know if you could cast from the watch, but I think you can probably build an app that does.
I mean,
You
that's
can use it
really
as a
cool.
remote right now. I've never tried to use it to actually queue up the stuff, but you can definitely use it to
And
like
you can pause and fast forward
Mhm.
and stuff
Yeah.
like that for flex.
Yeah, I mean, they're probably using the message API to
Yeah,
tell.
Pretty sure that's all done through the notification panel. Or
Yeah.
You can set a notification.
Yeah. Right now, I mean, everyone's trying to make money on watch faces. I mean, that's kind of like the latest craze is watch faces and building something unique in that space. I think there's a huge opportunity in real functional, B2B, B2C apps, games. I don't know if you guys use that Papercraft that's on the Huawei watch. There's a lot of OpenGL going on there, and it's really responsive and really fun and cool. It's Google Play is matured, right? A lot of us, if you didn't get an app out there, you might feel like you're lost in this sea of millions of apps. But with Wear, there's an opportunity to really make an impact. So hopefully you guys are interested in doing that.
Is Google going to build a separate watch OS on? See, right now Apple is doing before they connect. Now they have separate OS on watch, right? Is Google going to do the same thing? I mean,
Pretty sure that Wear is still the same OS as this. So it's still the same Android, just Wear put some stuff on top of it. I don't know, Patrick. I don't know if the actual Android platform is slimmed down for Wear.
Yep, let's say for us, is
Same.
runs on the East, runs on your phone.
Yeah.
Most of the stuff is specific to the platform.
Yeah, so they have like an API. If you like go into the API manager and Android Studio, you'll see there's like a Android 4.4 and a 4.4W, and then there's a 5.0.
Yeah, there's kind of three things with Wear. There's the Android OS, there's the Wear OS, and there's Google Play Services. And I think we can see that real quick in this emulator. Actually. Oh. So you can see right there, this is actually, running Marshmallow. Where's the Wear APK?
Under versions.
Yep, here you go. So this is the Wear specific components, and then here's the Google Play, and then there's operating system. So all these things combined kind of make the Wear platform. But this right here is still the same OS that runs on here. But they did take out the browser and some print functionality, and I think there's one other thing that they removed from the Wear API. No widgets, no printing, no browser. That's the only thing that's removed.
Can't print from your watch.
Yeah. Well, you could send a message to the phone to print. I mean, that's basically what you want to do. This does light processing. This does all the heavy processing. That's kind of
I think it was a good motive, when the motive this thing came out, there was a good ad that they came up with, which showed like use cases for a Wear device. Because everybody is struggling with like, why would I use a Wear device? Like, why would I put something on the phone? And then they came out with the ad, and then the ad kind of talked about the thing that you talked, like, just tap and go. Really not tap, 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 sit in there. I mean, like, it really should be like tap and go, because you're not, that's a thing that I struggled with. I got a Moto 360 when it came out, and then I still had glass. Right? And then when I looked at it, it didn't really appeal to me. I just returned it because it didn't make sense to me at that point, because whatever I was able, and also there was a constraint that I could only have either one of my devices connected to Android at that time, and either it should have been my watch or my glass. And then I do more with my glass than I get the functionality out of my the Wear. Even today, like I know I can do a lot more with glass than I can do with my with any of the devices out there. So I still choose glass over Android Wear. I mean a watch. But again, the use case for a watch really is not sit there and do. I mean like game, yeah, you can do that when you're there. But it's supposed to be like you said exactly, complement something on the phone and not really take over, take the place of the phone. That's why I don't think you will ever see an Android Wear come out with a SIM attachment in it that will completely replace your phone, because they won't have the enough horsepower to do all that. I mean, even if it did, it probably will burn your wrist because
Yeah. Yeah. I was really worried about how little RAM's on the device, but when I memory profiled that app, it was only like 3 megabytes of memory. I mean, and that was, using the the fragment pager adapter and sending list views across the wire and with some assets. It was really, really small. I think they've done a really good job at keeping the memory footprint of your app small. But yeah, it's all about the use cases. What use case really fits, and that's really up to us. Not really, Google can help with that, but that's up to us to build experiences that can extend to the watch and build a compelling use case where people want to buy it. And I think that's kind of the struggle right now. Is there enough use cases where people want to invest $500, $400, $200 on a nice watch?
I guess the key is to also add more and more sensors to the hardware. So that we can expand the use cases. I mean, there's only so much you can do with what's available right now.
Yeah, most definitely. Even the fit stuff. When I run or I cycle, I have to stop and make sure my watch is still before it takes my heart rate. That's really. I'm not going to interrupt my activity so I can get a heart rate. That kind of sucks. But what was I wanting? I wanted to say one more thing. Anyway, so that's it. Actually, one more thing. One thing that's really cool about Wear is if you buy a Wear device, it looks like Google's really made it so the life expectancy lasts. Even Android 6.0 Marshmallow is coming to the Moto 360, which has been out for how many years now, Greg? 2 years. So when you make that investment, you know that it's not going to just be obsolete. They have made a commitment to push the new OS to that watch. So that investment you make, you can rest assured that it's not just one and done, which some Android devices unfortunately have been. Is you buy it and you're locked to that OS. Wear is not like that.
Google does that even with their phones, right? Even with the Nexus line of phones, when a new OS comes out, you get the update no matter.
Yeah, but he's saying the lifetime for that is longer than your average device, because a lot of phones will cut out after a year and a half. But they've been committing pretty well to the Wear.
We're talking about the OEMs. Yeah, OEMs will cut it off, but Google doesn't cut off any of the devices.
Yeah, I mean the Nexus devices are managed by Google, but even that Samsung Gear Live, I mean, Samsung is always kind of, once it's out there.
OEMs always do that. They don't have the
Yeah.
resources to keep portion.
But that's the cool thing. OEMs.
The watches, though.
Hmm?
The Google has a lot tighter grip around the watches
Yeah.
than they do phones.
Yeah.
And that's what he's saying, is that
with a phone, regardless of the manufacturer, it's going to get, I mean, I bought this when it first came out, and yeah, I will be getting Marshmallow on it, and it's a 2-year-old watch that a 2-year-old Motorola phone that's not Nexus will not be getting Marshmallow. Because even though Google will roll it out for that phone, the manufacturer may not, and the carrier certainly won't do it.